Okay, today's lesson will center on Cramer's rule. Cramer's rule gives us another strategy on how to solve a linear system. I'll start off with the basic 2x2 linear system of equations, and of course you can use substitution, linear combination, or elimination in graphing to figure out the solution to a system of equations. But we also have another way which involves Cramer's rule, which says this, that you can come up with what we call a coefficient matrix. A coefficient matrix would just be, for example, in this particular one, taking the coefficients of the first equation, 5 and 7, and then 6 and 8, okay, for the second equation. This is going to make a coefficient matrix, okay? What we're going to do, you're going to solve for x by finding the determinant. Now remember, the determinant, when they want you to find the determinant, they're going to use a different marking. They're going to use vertical bars instead of those enclosed brackets. So 5 and 6 and 7 and 8. So the determinant of the coefficient matrix goes in the denominator. So you're going to make like a fraction. In the numerator, watch what happens. You're going to take the values of -1 and 1, what both of these equations equal to. They're going to replace the coefficients of 5 and 6 and make another matrix. So watch this. -1 and 1 is going to be the first column. It replaces the 5 and 6 coefficients. And then it's going to have 7 and 8. So 7 and 8, which are the coefficients for y, stays. So I can find what x is going to be just now by taking the determinant of the numerator. Remember, determinants, you can watch my previous videos if you need to refresh on determinants, but to find the determinant, you can just take -1 times 8. All right, multiply that minus, okay, and I'm going to put this in brown, the second diagonal, which is 1 times 7. So we're going to get -1 times 8, which gives us -8, minus 7 gives us -15. That's in the numerator. Okay, that's in the numerator. So now we do the same exact thing for the denominator. We find the determinant, which says go 8 times 5 minus 7 times 6. You just take those two diagonals, all right, and just do the product. 8 times 5 is 40, and then 7 times 6 is 42. So in the denominator, you can get -2. So when it's all said and done, x is going to be -15 over -2, which is 15 halves. You can express that as a decimal as 7.5. Okay. Now for y. All right, so let me kind of make this smaller. For y, I'm going to do the same exact, very similar to what we did for x. Okay. The denominator will just be the coefficient matrix, the determinant of it. So 5, 6, 7, 8, nothing changes there. However, the numerator is going to change. So in this case, the first column is actually going to be 5 and 6. We keep 5 and 6. -1, 1 is going to replace now the coefficients for the y's. -1, 1. Okay? So that's the setup. That's the setup. So now what we're going to do, We're going to find the determinant. Well, we already found the determinant of the denominator. That's going to give us negative 2. Now we got to find the determinant of the numerator. So again, we just do 5 times 1. Which is going to be 5 minus, and then we're going to go ahead and do the other diagonal, negative 1 times 6. So we're going to get negative 6 for that one. So 5 minus the negative 6 gives us 11. So 11 over negative 2, which gives us negative 5.5. So our solution to this system, we saw by Cramer's method using determinants of 7.5 for x, negative 5.5 for y. Okay, so that's a 2 by 2. Let's say, for example, we had a 3 by 3s. In this particular case, we have 3 equations, 3 unknowns. And we're going to do the same exact thing. We're going to grab the coefficient matrix first. So to find out what x is going to be, we're going to make a fraction. Now, let's do the denominator first, because that's the coefficient matrix. We just grab the coefficients out in front of the variables. So 1, 1, negative 1. 2, negative 1, positive 1. 1, negative 2, positive 3. And we're going to find the determinant of that. So we express that by putting in those vertical bars. Now, in the numerator for x, watch what's going to happen. In this case, we're going to take negative 2, negative 5, and 4. Okay, let me kind of put it like this. Negative 2, negative 5, and 4, it's going to replace the coefficients out in front of x. It's going to replace it. So it's going to be negative 2, negative 5, and positive 4. The y coefficient is going to be the second column, 1, negative 1, and negative 2. Z, the coefficients for z, is the third and last column, negative 1, positive 1, and positive 3. And you're again going to find a determinant. So if you recall, to find the determinant of a 3 by 3 matrix, we rewrite the first 2 columns, negative 2, negative 5, and 4. 1, negative 1, and negative 2. Okay? And what's going to happen? I'll kind of color code it for you. I'll use the first one starting in blue. You're going to multiply, starting with negative 2, that first diagonal. Negative 2 times negative 1 times 3. That's going to give us 6. You're going to add that to the diagonal product that's right next to it. 1 times 1 times 4 is 4. And then one more, negative 1 times negative 5 times negative 2 gives us actually a negative 10. So you're going to add all that. That's going to give you 0. Okay? So now what's going to happen? We're going to subtract that to whatever the red set is. I'm going to color code it for you. So we start in the opposite. So we're going to go now 3 times negative 5 times 1. Okay, so that's going to become negative 15. And I'm going to put parentheses around. I'm going to group this second set. Okay, because that subtraction sign, you got to be very careful. So I've seen quite a few mistakes where students forget to incorporate that and can cause you to miss the problem. So we're going to go ahead and group this second set together. So negative 15. Take negative 2 times 1 times negative 2. 4 times 1 is 4. All right, and then 4 times negative 1 times negative 1 gives us also positive 4. So this second set is going to be negative 15 plus 8, which is negative 7. So to find the determinant of the numerator is actually 0 minus a negative 7, which gives us 0 plus 7, 7 in the numerator. Okay? Now, we keep going. We say, well, hey, we got to be able to find the determinant of the coefficient matrix, which is in the denominator. So again, I rewrite the first two columns. 1, 2, and 1. 1, -1, and -2. I'm going to do the same exact process as I did with the numerator. All right, I'll color code these to help us. All right, so 1 times -1 times 3 gives us -3, plus 1 times 1 times 1 is 1. -1 times 2 times -2 gives us 4. Okay, so that's going to give us, when it's all said and done, -3 plus 1 is -2 plus 4 gives us +2. We're going to subtract. And we got a second set. We'll put it in red. 3 times 2 times 1. 6. -2 times 1 times 1. -2. 1 times -1 times -1. We're going to get 4 plus 1 is 5. So this is going to give us -3. 2 minus 5 is -3. So x is going to be -7/3. All right. And so what we're going to do now is just follow that same process, a similar process, to find y and z. So I'll just kind of set it up for y and z. Y would just be equal to, again, the same coefficient matrix, which is 1, 1, -1, 2, -1, 1, 1, -2, and 3. It's the same thing that we did on bottom. So the bottom is going to, and then you find the determinant of that, okay, which we know should be -3. All right, on top though, what's going to happen is these values, -2, -5, and 4, is going to replace the coefficients for the y. X's stay the same, so x's is the first column now. 1, 2, and 1 to find out what y is. But then the second column, the middle column, -2, -5, and 4, will replace the y coefficients. And then z, -1, 1, and 3. Okay? Now, when it's all said and done, the determinant for the numerator for y, you should get -22. So y is going to be just equal to -22 over -3, which gives us +22/3. So x is -7/3, y is 22/3. We have one more, ladies and gentlemen. We have to find z. So the bottom is going to stay the same. 1, 2, and 1. -1, sorry. 1, -1 and 2. -2 rather. And then -1, 1, and 3. Okay, so that is consistent for x, y, and z. It's just a coefficient matrix. So then what's going to happen is that, hey, x, coefficient for x is going to be 1, 2, and 1. Coefficients for y will be the middle column, 1, -1, and -2. Now z is going to be replaced. The coefficients for z is going to be replaced with the values of -2, 5, and 4. -2, -5, and 4. Okay, so when you do the determinant for that, on bottom you should get -3. And then on top you should get -21 when it's all said and done. So z should be 7. So our solution to this 3x3 system, x is -7/3, y is 22/3, and z is 7. Ladies and gentlemen, that is how to solve a system 2x2 and 3x3 using Cramer's rule.